What does it look like? Magnitude of x squared minus 9x. Hmm? Yeah, good. So let's go to the side and talk. So we've got y equals x squared minus 9x. That's my function to start with. Yeah? The base function. Which is a parabola. Okay. Positive. What are the two intercepts? 0 and 9. Good, because 0 equals x squared minus 9x. X is common. So we've got 0 and 9. We get scaling. That's that. Yeah? With no magnitude. Now we bring in magnitude. So we're taking the magnitude of the whole lot, which really means you now produce that graph. Happy with that? Talked about magnitude. When you're magnituding the whole function, it means that you have nothing below the x's. Okay. So, if I want to define this, to do my derivative, I can't derive with magnitudes, the way it is. So what I need to do is write it as the two functions that it can be, 2 or 3 functions that it can be. What are these red bits here? That one and that one. What would be the name of that? What function is that? Is it the original or is it the flipper? The original. What was the original equation that we drew? X squared minus 9x. So, the function is x squared minus 9x. Right? That's the positive bit. That's the bit that stayed the same. So y equals x squared minus 9x. Done. For the domain of x is less than 0 and x is greater than 9. Yep. So you remember when you do modulus, it's going to have a positive function that's like the original, and then it's going to have the flip. The flip is the negative of what you had. So I'm going to write negative x squared minus 9x. That's this bit. Because all I did was go to the original and flip everybody over. So when it was negative, it became positive. How do you do that? You just take the negative of it. Which means I now get the function negative x squared plus 9x. Okay. Original, flip. The domain for this is between 0 and 9. Inside this zone. Right, so when it comes to modulus, write the original one and write the new one down. Just split them up. Now, you've got a simple function, you can find the derivative. Therefore, dy dx equals, there's going to be two derivatives. This one, 2x minus 9, simply deriving it, when x is less than 0 and x is bigger than 9. That's the name of this one. And then the derivative of this will be negative 2x plus 9 when x is between 0 and 9. So take your positive, define it, derive it. Take the negative, define it, derive it. Now I want to sketch that here. Okay. Now we're sketching. Now notice, or just one thing here, when it comes to this, technically I should have decided one of them to be equal. Doesn't really matter. Right? Let's say I took this one. Right? So I'm saying that this black dot in here, that does exist for this function. When I do the derivatives, there will be no equals to. That's very important. Because when you derive stuff, you cannot find a derivative at a corner, an endpoint, or a break. Right? There are three conditions of differentiability. You cannot derive here. Right? Do we know that? And we don't know that. Some do, some don't. Right? The definition of derivative is you should be coming to the same answer from both sides. Same gradient from both sides. You've got to be able to sandwich the answer. If I looked at gradients here, as I'm getting closer to that dot, this is telling me a gradient's negative. If I look on the gradient here, the gradients are positive. You're not sandwiching the same point. Right? One guy reckons the gradient's negative 1, the other guy says it's minus 1. We're not sandwiching, so you can't do it. Right? You can never find a gradient at a sharp corner. So when I'm drawing this, I'm going to draw 2x minus 9, which is a straight line, for x is less than 0 and x is bigger than 9. So that curve there now has to be represented by a straight line. So we'll go to 0. When x is 0, that gives you minus 9. So we're down here at minus 9. Yep. When x is 0, minus 9. What do I do? Where's the graph? There's a starting point. Up, down, flat, across.
Like that.
That way? Yeah? Why? Why?
Because that's the first positive graph you're drawing.
Yeah. You're drawing this, which is 2x minus 9, positive straight line, negative 9 is the intercept. So we're going to draw this.
It's negative.
Right?
To 9. Like that, all the way to 9. I mean, yeah.
Yeah. Right. If I wanted to draw 2x minus 9, it would go like this, wouldn't it?
Yeah.
It goes through negative 9, has a gradient of 2.
But that's
Yeah.
not the domain.
But we don't exist. We only exist less than 0 and more than 9. So draw your straight line, that equation, rub out the bit in the middle. Okay? When 9 goes into that equation, 2 9s are 18, take away 9. So that corresponds with 9. So I just took that one, drew a straight line, rubbed out the bit in between. Open circles, vital, because you can't find derivatives at. Now I've got to draw this one. Well, that's negative 2x plus 9. That'll just go like that, wouldn't it? 9 is a y-intercept, gradient of negative 2. Bang. But that doesn't exist less than 0, and it doesn't exist more than 9. Put open dots on there. So if I was drawing the derivative of this, that's the graph. It's 3 zones. Zone 1, less than 0. Zone 2, between 0 and 9. Zone 3, more than 9.